This video is intended to show you how to do an antiderivative where one of the factors is what we call an irreducible quadratic. So here's my original, negative 9x squared plus 17x plus 32 is in the numerator over the denominator is already factored, x minus 4, and x squared plus 36. This is factored as much as possible, and it's what we call an irreducible quadratic factor because we can't factor it any further. If there had been a minus, we could factor it further, and we'd have three linear factors, and that'd be great, but not possible in this one. So first, let's talk about the setup. So first, we're going to break this into a over x minus 4 plus, now, because this is an irreducible quadratic, in the numerator goes a linear factor. Now, it might not be linear, but we have to account for the possibility that it might. It'd be similar if you had an irreducible cubic, your numerator would be a quadratic. We're going to need that for our system because we're going to have three equations, so we need three variables. So let's talk about how we find A, B, and C. Now, in this video, I'm just going to focus on the numerator. In other videos, I've shown why the setup works the way it does. What you want to think about is going the opposite direction and you're finding a common denominator. So what would A need to be multiplied by to get a common denominator? Well, it needs to be multiplied by the x squared plus 36. And similarly, the bx plus c, what would it need to be multiplied by? Well, it needs to be multiplied by the x minus 4. So that is the numerator. If we were to find a common denominator and add these together, we want them to be equal to the numerator on this side, which is negative 9x squared plus 17x plus 32. Now we're going to multiply out the left-hand side, and so this way we can set up our system of equations. So we distribute the a, we got ax squared plus 36a. Here we have to FOIL, so multiplying these we get bx squared. Doesn't matter what order you do them in, just make sure you get all of them. Minus 4bx. Here's going to give us a plus cx, and then finally a minus 4c. Again, this is going to be equal to negative 9x squared plus 17x plus 32. Now we set up our system of equations, and I'll show you how I like doing this. I like doing it by powers. X squared, x to the first, and I write it as x to the 0, but that's our constants. And I'm going to have an equation for each. What that means is I'm going to look for all the coefficients that have an x squared. So, for instance, a is multiplied by x squared. I don't need the x squared. It's as if I factored it out over here. A positive b is multiplied by an x squared, so we took care of that term, and we took care of that term. And there's no other x squareds. Now, what does that equal? Well, we go over to this side, and in front of the x squared is a minus 9. I left the space for the c so we can, because we'll be setting up a system of equations in a matrix after this. Now we go to all the terms with an x in them. That doesn't have an x, this one does, and again, we don't need to pull the x in, it's already here. Minus 4b. I like lining these up, and you'll see why shortly. And then that takes care of this term, and then we have a plus c. And so then we look for the x terms over on this side. Let's cross that out. The x term is right here. So it's going to equal 17. So hopefully you can see where these are coming from. Do the last one for the constants. We have 36a. No b's, and then minus 4c right there. And the constant term needs to be equal to 32. So this is going to be what makes up our system. Now, what we're going to do is we're going to use the graphing calculator to do a matrix. Let me show you first how we set up the matrix. You do not need to have a whole lot of experience with linear algebra to do this. This is what's really nice about this. All I'm going to do is take the coefficients. So this first line, I've got a coefficient of 1, 1, 0, and negative 9, because there's no c. 1, 1, 0, and negative 9. Next row, I've got 0, minus 4, 1, and 17. And last row, I've got 36, 0, and minus 4, and then 32. Feel free to pause the video so you can see where all of these are coming from. Sometimes you'll see people put a dotted line here because we have a square matrix here with the solution vector added on. Don't worry about that. Again, this isn't linear algebra. I just want to show you a nice way of using the calculator to solve this. So here's my graphing calculator, and we're going to do a matrix. So you can see matrix is right here. So we will do second matrix, and we're going to want to edit a matrix. I'm going to do a fresh one just so you can see what it will look like the first time you do it. We're doing a 3 by 4. And you can see there's my entries. Now we'll just enter what we have going across. 1, 1, 0, negative 9, 0, negative 4, 1, 17, and then lastly 36, 0, negative 4, 32. Okay, make sure all our entries are correct. And then once you have this entered, you want to quit out of here. That's the easiest way. So we'll quit. And if you're not sure, we can go into the matrix option. And if we just bring up C, there's all our entries. Now we haven't done anything with it yet. That's what I'm going to show you next. Now we're going to do some math with it. So we're going to go into our matrix menu. And now we're going to go over to math. And we're going to go down to RREF, which stands for row reduced echelon form. I've also heard it called reduced row echelon form. Either way, you get the same letters. You don't need to know those terms, but if you're interested, that's what it stands for. This is going to solve our matrix for us, if it is solvable, and this one is. So we do RREF. Now we have to put in the matrix that we want. So we go second matrix, and this time we do just the name, and we're putting in C. Close the parentheses, hit enter, and we now have our solutions. Now I don't want to deal with decimals, so I am going to turn those into fractions by doing math fraction of my answer. And now this is the way this works. 1 times A is this, 1 times B is this, 1 times C is this. So there are my answers. So let's get those recorded. So A, bring that back up. A is negative 11/13. B is negative 106/13. C is negative 203/13. Okay, now that we have those recorded, let's put our calculator away and see how we start solving this integral. So I'm going to plug these in for A, B, and C up into our partial fraction modified integral. So negative 11/13 over x minus 4. It's going to be a little messy right now. We're going to clean it up a bit. Minus 106/13 times x minus 203/13 all over x squared plus 36 dx. All right, here's what we're going to do. I'm going to start pulling out fractions, and I'm also going to rewrite this one because right now, having that linear with a y-intercept over the quadratic isn't good for us. So I'm actually going to split that into 2 separate fractions. The other thing I'm going to do is I'm going to pull all the constants out front to make this a little bit easier to look at. So negative 11/13 times the integral of 1 over x minus 4 dx, and I'm going to split them into separate integrals. So minus 106/13 times the integral of x over x squared plus 36 dx. So that's taking this first part of the fraction. And then we'll have the second part, which will have this messy constant. So 203 over 13. It's still going to be minus because of the negative. And now it'll be 1 over x squared plus 36 dx. Okay, now we're going to work on each of these separately. Let's start with ones we can solve and what we need to do for the other ones. So this one was ready to solve. This is just a natural log. So negative 11 over 13 ln of the absolute value of x minus 4. I'm not going to put in a plus c yet because I'm just going to put in a single plus c at the very end. This one here is set up perfectly for a u sub. I'm going to let u equal x squared plus 36. Well, then my du is 2x dx. So I need to make a little modification on this one because I need it to be 2x dx, which means, so now we're going to have minus. We can actually reduce this. 106 divided by 2 is 53, so we can make that a 53 over 13. And then now, putting in our u, we're going to have 1 over u, and then our du is the 2x dx, so that works out perfectly. We'll solve this in the next step. And let's talk about what we're going to do with this guy here. I'm going to put the 203 over 13. All right, so what I want to do is this looks a lot like an arctan. I'm going to show you how we can make it an arctan. What I'm going to do is I'm going to multiply on top and bottom by 1 over 36. All right? And realize for the bottom that does distribute. So what happens here? I've now got 1 over 36 on top. Down here, I've got 1 over 36, or I could write it as x squared over 36 when I distribute here, plus 1 dx. Okay, I'm going to have another step of cleaning this one up, and I'll show you it in the next step. Now again, this guy's done. Negative 11 over 13 ln of the absolute value of x minus 4 minus 53 over 13. This will be the natural log of the absolute value of u. Again, I'm saving the plus c for later. We will have to substitute back. I'll do that in the next step. All right, so what's going on here? So I got 203 over 13. I'm going to pull the 136th out front so I can deal with it later. And here's what I'm going to do with what's in here. Right now I've got 1. This, I'm going to absorb that 36 into the square, which is going to give me x over 6, the quantity squared plus 1 dx. Now, if you're not sure what's going on here, think about squaring this. I did x squared over 6 squared. It would get me back to the x squared over 36. Now, this is also a u sub. I'm going to let u equal the x over 6. Then du is 1/6 dx. So once again, need to make a little adjustment so I can get this in. I need to put in a 1/6 here. So that means on the outside, to compensate that, I have to put in a 6. Okay? All right, where are we at? We've got the negative 11 over 13 ln of the absolute value of x minus 4 minus 53 over 13. Now let's sub back and be done with this. Natural log. Now one of the things, because we're putting in x squared plus 36, we don't need the absolute value because it'll always be positive. Doesn't make it wrong, we just don't need it. Let's clean up this constant out in front of this one. So 6 times 1/36, well, that becomes a 6. So now we have minus 203 over 13 times 6. 13 times 6 is 78. So we have minus 203 over 78. So let's put in our u, which will be 1 over u squared plus 1 du. Now we can clearly see the arctan. And now we can finish this guy off. Negative 11/13. ln of the absolute value of x minus 4 minus 53 over 13, natural log of x squared plus 36 minus 203 over 78. And this will be an arctan of u. But I'm going to do this in one step since it's the last step. I'm just going to substitute back in the x over 6. And then now I'm going to put in my plus c for the indefinite